Do animals know when you're sad? Okay, stop. I know exactly what this sounds like. Do animals know when you're sad? Is the kind of question that usually arrives attached to a photo of a golden retriever resting his head on someone's knee, with a caption designed to make you feel something you're a little embarrassed to feel. It sounds soft. It sounds like a question people ask because they've already decided they want the answer to be yes. So let me tell you why it isn't that question at all. Right now, there are laboratories measuring cortisol in dog hair over a period of months. There are researchers timing, to the second, how long it takes an animal to break through a door. There are people playing recordings of a stranger sobbing to house cats, and other people collecting human sweat on gauze pads to find out what a nose can pull out of it. This is a live scientific argument, with genuine disagreement, and the two answers most people give are both wrong. The first wrong answer is the sentimental one. Of course he knows. Look at his face. The second wrong answer is the one that sounds smarter, the one you give at a dinner party to seem rigorous. No, that's projection. He's just reacting to a change in your routine. Both of those are too small, and the truth sitting between them is stranger than either. It's not one thing. It's never just one thing. Start with something we never examine, because we're standing on the inside of it. Sadness feels private. It feels like weather happening in a sealed room. You can be devastated in an open-plan office and reasonably assume nobody knows. But biologically, that's a fantasy. When your mood drops, you don't just feel different. You become a measurably different animal. Your posture changes. The speed and variety of your movement changes. The pitch range of your voice narrows. Your breathing rate shifts. Your face does about a dozen small things you have no conscious control over. And your body chemistry changes, which means the air around you changes. You are not hiding. You are broadcasting on at least 4 channels simultaneously, and you have no off switch. Now hold that thought next to the timeline. Reading distress in another body is not a dog thing, and it's not a human thing. It's a very old thing. The ability to notice that another animal has become slower, quieter, more erratic, and less predictable is one of the most valuable pieces of information in the natural world, because that information tells you whether to help, whether to flee, or whether to attack. It predates dogs by tens of millions of years. It predates primates. It's older than we are by an amount that makes our entire species look like a rounding error. So the question was never really, can they detect it? Something is always detecting it. The question is, what happens next, and what, if anything, they think it means. Let's go. Start with what physically leaves your body and reaches theirs. Your face is the obvious channel, and it's the one people are most skeptical about. Surely a dog isn't reading micro-expressions. Except in 2016, a team led by Natalia Albuquerque at the University of Lincoln ran an experiment designed to test something much more specific than face reading. They showed dogs 2 photographs side by side, one of a happy human expression, one of an angry one. Then, from a hidden speaker, they played a single vocal sound with a clear emotional tone. Not a command, not the dog's name, just a voice. The dogs looked significantly longer at the face that matched the emotion in the sound. That result is more important than it looks, so give it a second. Matching a sound to a face isn't cue reading. A dog can learn that a raised hand means something without having any idea what an emotion is. But to link an angry voice to an angry face, an animal needs some internal category that both of those things belong to. It needs a concept, not a cue. The paper, published in Biology Letters, was the first solid evidence that a non-primate can build an abstract representation of a human emotion. Then there's movement, which is where dogs are genuinely, unfairly superior to us. In clinical psychology, there's a term, psychomotor retardation, described in detail by Christina Sobin and Harold Sackeim in 1997. The slowing of movement and speech that accompanies low mood. Your steps get shorter. Your gestures get smaller. You pause longer before you answer. You are, quite literally, moving like a different creature. And you are living with an animal whose visual system is optimized for detecting motion and change, watching you for hours a day, every day, for years. Your voice leaks too. Speech researchers have spent the last 2 decades building depression detection algorithms from audio alone, and the markers they use are consistent. Reduced pitch variability, slower speech rate, longer pauses. The words can be perfectly cheerful. The carrier signal underneath them isn't. And then there's smell, and this is where it stops being metaphorical. In 2011, a team led by Gelstein published a study in Science on human emotional tears. They collected real tears from people crying and had men sniff them. The tears were odorless. The men couldn't consciously identify them at all. The men's testosterone dropped. Their physiological arousal dropped. Tears are not just salt water. They are a chemical signal, and they work on a species with a nose as mediocre as ours. Seriously, think about this for a second. That's what it does to a human. Now consider that in 2018, Biagio D'Agnello's team collected sweat from people who had been made frightened and from people who had been made happy and released those samples into a room containing dogs, their owners, and a stranger. The dogs given the fear samples showed more stress behaviors, had higher heart rates, and made significantly more contact with their owners while avoiding the stranger. They had never met the person who produced the sweat. They were reading a chemical postcard from someone who wasn't in the building. But here's where it gets interesting. Because detecting something and understanding it are completely different achievements, and this is exactly where the sentimental answer falls apart. Test 1. In 2012, Deborah Custance and Jennifer Mayer at Goldsmiths brought 18 household dogs into a room with their owner and a total stranger. On cue, one of the two humans would talk, hum, or cry. The dogs overwhelmingly approached whoever was crying. Now, the obvious objection is that a crying human is upsetting, and the dog is running to its owner for comfort. Except that's not what happened. When the stranger was the one crying, the dogs went to the stranger. They walked past their own person to reach a sad human they had never met, and they approached in a low, submissive, nuzzling posture, not the way a frightened dog seeks safety. Test 2, and this one has a name I love. In 2018, Emily Sanford's team ran a study officially titled Timmy's in the Well. They put an owner on the far side of a door held shut by magnets, weak enough for a dog to push through, but not obviously openable. The owner either cried or hummed, "Twinkle, twinkle, little star." Roughly the same number of dogs opened that door in both conditions, but the dogs whose owner was crying got through it dramatically faster. And now the part that reframes everything. The researchers also measured stress in those dogs. The ones who pushed through the door were not the most distressed animals. They were the least distressed ones. The dogs that were most upset by the crying froze. They paced, they whined, they stared at the door, and they did nothing. This is not an exaggeration. That single finding is the cleanest distinction between two things we constantly confuse. Emotional contagion is catching someone else's state. You feel bad because they feel bad, and now you have your own problem to deal with. Empathy is registering that the bad state belongs to them, and staying calm enough to act on it. Being overwhelmed by your sadness and helping with your sadness are not the same skill. In that study, they were almost opposites. And none of this machinery is exclusive to dogs, which is the part that should genuinely rearrange your thinking. In 2006, Jeffrey Mogil's group published work in Science showing that mice experience more pain when a familiar cagemate is also in pain, but only if they know each other. In 2011, Inbal Ben-Ami Bartal, Jean Desetti, and Peggy Mason showed that a rat will work to free a trapped cagemate with no reward, and will do it even when there's chocolate available as an alternative, and will then share the chocolate. In 2016, James Burkett's team found that prairie voles console a stressed partner by grooming them, and that the behavior disappears if you block oxytocin in the anterior cingulate cortex, the same brain region humans use for empathy. Ravens do it. Chimpanzees do it. Documented by Frans de Waal back in 1979. Consolation is not a gift we taught them. It's ancient hardware, and we are one of the species running it. But here's where it gets stranger, because there's a hole in everything I just said. None of these animals have the concept sad. Sadness is a human word wrapped around a human bundle of feelings. Loss, grief, the specific ache of remembering something that isn't coming back. No dog has that category. No cat is thinking, she's depressed again. So what are they actually tracking? The best current answer is that they aren't reading the emotion at all. They're reading the deviation. Every animal that lives with you carries a running statistical model of what you normally are. How you move, how you sound, how fast you come down the hallway, what you smell like at 7 in the evening. That model is built over years and updated constantly. What gets flagged isn't sadness. It's the gap between you and your own baseline. Here's something nobody talks about enough. That means it's not a species-level ability. It's a private dialect, and it only works on people the animal has studied. Cats prove this beautifully. In 2016, Mariah Galvan and Jennifer Vonk tested whether cats could distinguish a smiling human face from a frowning one. The cats did behave differently. More purring, more rubbing, more time on the lap when the person was smiling, but only with their own owner. Put a stranger in front of them making the exact same faces, and the effect vanished. The cats hadn't learned what a smile is. They had learned what their human looks like when things are fine. That's a little unsettling when you think about it, but here's the wild part. In 2019, Lena Roth's team at Linköping University measured cortisol in the hair of 58 dogs and their owners. Hair cortisol, which gives you a record of stress stretching back months rather than minutes. The dog's long-term stress levels were synchronized with their owners, not correlated with the dog's own personality, correlated with the owner's personality. Over the scale of a year, your dog's stress isn't reacting to your bad days. It's a smudged copy of your entire emotional life, which raises the obvious question. If this ability is so old and so widespread, why does it feel like such a gift when it happens to us? Because outside your living room, the same signal gets read completely differently. A wild animal that becomes slower, quieter, less coordinated, and less predictable has just announced something to everything around it. When David Mech spent years documenting wolves and moose on Isle Royale in the 1960s, the pattern in the kills was unmistakable. Wolves tested enormous numbers of moose and killed very few, and the ones they killed were overwhelmingly the calves, the old, and the sick. Predators aren't hunting animals, they're hunting deviations, the individual moving wrong. So the readable body isn't the rare thing. Every creature on Earth is legible when it suffers, and for most of the history of life, being legible in that way was the most dangerous thing that could happen to you. So, do animals know when you're sad? They know something. They know the shape of you has changed. They know it through your face, your voice, your motion, and your chemistry. And they knew it before you decided to tell anyone. What they don't know is why, or that it's temporary, or that it has a name, or that it belongs to you and not to them. But I don't think that's the interesting part anymore. The interesting part is that the noticing was never rare. Everything notices. The whole living world is built to detect the moment another body stops working properly, and almost all of it evolved to use that information to keep its distance, or to close in. And then there's this handful of species, a few thousand years of sleeping in our rooms, eating at our feet, watching us more carefully than anyone else in our lives ever has, that took the oldest vulnerability signal in nature and did something with it that makes no evolutionary sense at all. They walk toward it. So when a dog puts his head on your leg on the worst night of your year, he probably doesn't know what sadness is. He doesn't know what happened, and he doesn't know that it ends. He just knows that you are not the you he has memorized, and that somewhere in a piece of brain far older than either of you, the instruction is to shorten the distance. And that instruction was never his, and it was never ours. It's the same one, running in a rat, in a vole, in a raven, in a chimpanzee, in a 2-year-old child who has never been taught what comfort is supposed to mean. Because the story of an animal knowing you're sad was never really a story about animals. It's the story of one very old piece of inheritance, the impulse to move toward a body that has stopped working right, instead of away from it. And it's written on every single one of us. If you found this interesting, remember to like and subscribe, and thanks for watching.